Let us keep travelling from where we left off. We are still chasing the edge of what nature allows. We cannot reach the speed of light, but we can get close enough for time itself to change. On Earth, time feels shared. A second feels like a second for everyone. We live as if one great clock sits behind the world. But the universe is more subtle. Time depends on motion. If you move fast enough, your time runs more slowly than the time of someone who stays behind. This is not just an idea. It has been tested in the real world. In the early 1970s, scientists took atomic clocks onto passenger aircraft. Other atomic clocks stayed on the ground. The planes flew long routes and then returned. When the clocks were compared again, they did not match. The flying clocks were slightly out of step. They had lost a tiny amount of time. The difference was small, far too small to feel. But it was measurable. Even on Earth, motion can change time. Now take that truth and push it much further. At CERN, near Geneva, particles are pushed to more than 99.9999999% of the speed of light. That is a real, measured speed. It is not a metaphor. It is everyday work in a laboratory. Now let us take one careful step in imagination, not into fantasy, just into a what if that follows real physics. Say we learn to propel a spacecraft to that same fraction of light speed, 99.9999999%, still below the limit, but close enough for time to separate. Now give the ship a destination, Proxima Centauri b, a world around the nearest star beyond the Sun, just over 4 light years away. From Earth's point of view, this is not quick. Even at that extreme speed, the round trip is about 9 years. 9 years of life continuing without the astronaut. But inside the spacecraft, the story is completely different. At this speed, time for the astronaut runs far more slowly. So those 9 years on Earth become about 11 hours for the astronaut. 11 hours. Not 11 hours of frozen time, just ordinary time, meals, rest. A long, strange day inside a sealed cabin, then the ship returns to Earth. The astronaut steps outside. The air feels familiar, gravity feels familiar. The sky is the same sky, but the world is not the same world. On Earth, 9 years have passed. People have grown older, children have grown up. Some faces have changed in ways you cannot undo. Some people may not be there at all. The astronaut has missed nearly a decade. Yet the astronaut has only lived through a handful of hours. This is the real meaning of time dilation. Speed does not only move you through space, it moves you differently through time. And there is a quiet shock inside that, because it means time is not universal. There is no single now that belongs to everyone. There is your time along your path, and there is Earth's time along its path. Most of the time, those paths stay close, so close we never notice. But near the speed of light, they can pull apart, not as a metaphor, as a measurable fact. And once you see it, the universe feels deeper, not colder, just more honest. Because time is not only something we watch pass, it is something we travel through, quietly, moment by moment,